Why are load paths crucial for F1 chassis? Imagine a race car zooming around a track, taking sharp turns and hitting high speeds. Behind the scenes, a complex system of forces is working through the car's structure. That's where load paths come into play. They are the routes that forces from the suspension, engine, aerodynamics, and driver follow through the chassis. Think of load paths like the roads that carry traffic smoothly from one point to another. If these roads are well designed, forces are transferred efficiently, keeping the car stable and safe. If not, stress can build up and cause damage or poor handling. In F1 cars, the chassis needs to be both very strong and very light. To achieve this, engineers design a network of tubes or composite materials arranged so that forces travel along the shortest, most direct paths. This minimizes bending or twisting stresses that could weaken the structure. They often use triangulation, connecting points with triangles, because triangles are naturally stable shapes that resist deformation. This makes the chassis rigid, so it doesn't twist when the car is cornering hard or hitting bumps. Proper load paths help the chassis stay stiff in torsion, which is the twisting force. This stiffness is vital because it makes handling predictable and allows the suspension to work effectively. When the suspension is attached at specific points, the load paths ensure that forces from the wheels are transferred directly through the chassis. This helps maintain balance and grip, especially during high-speed turns. The layout of the chassis is also influenced by load paths. Engineers position major components and suspension attachment points carefully so that forces flow through the shortest and strongest routes. They often use a 3D triangulated space frame or a carbon fiber monocoque structure. These designs are not just about strength but also about managing impact forces in crashes, protecting the driver. In essence, load paths are the backbone of F1 chassis design. They make sure forces are handled efficiently, keeping the car lightweight, stiff, and safe. This directly impacts how the car handles, how fast it can go through corners, and how well it absorbs shocks from the track. Without well-planned load paths, even the best engine or aerodynamics wouldn't be enough to make a competitive race car.